if AI training is more or less like writing software, inference is like deploying it globally as so people can use it. It requires totally different infrastructure. You have handled high latency sensitive use cases like live sports and global cybersecurity. How do the lessons from those challenges apply to AI infrastructure today?
Yeah, that's a great point. And I do see a lot of parallels to the early days of the web. Also, I think some of the changes that happened maybe a decade or so ago in cybersecurity. So in many ways, people say this all the time, history does repeat itself. And it's kind of repeating itself for the umpteenth time here. So while there's obvious differences, there's a lot about what's happening now that I think does parallel what we saw in the early days of the web. As the web was getting popular, really transforming the internet, there were a lot of concerns that the web simply wouldn't scale to meet the demand. And in many ways, those concerns probably were well-founded because you did have a situation where web applications were centralized. Now, we were pre-cloud, but we did have hosting providers. And arguably, the hosting providers back then were even more centralized than today's hyperscalers. By and large, most of the infrastructure was, in the US, for example, was heavily located in places like Ashburn and San Jose. So every time you used a web application, you had to traverse large distances into a handful of centralized locations. And while that might have been okay in the very early days where a website was a pretty static thing, just some text, maybe a few images, as you move into video, for example, and large demand for that video, you simply cannot meet the bandwidth requirements and the latency requirements through that centralized model. And that's really, I think, what led people to jokingly say that the World Wide Web should be, called the World Wide Wait. And people speculated that the web would simply collapse. And really that concern was the beginning of Akamai, where, Tom and Danny, the two founders, came forward with a better approach, math, algorithms, distributed systems, rather than brute force. And they showed that you can actually deliver websites and web applications from the edge of the internet, dramatically increasing the available bandwidth, dramatically lowering the latency. And really, that's what made the web work. And that was a critical ingredient also as the web transitioned from these static sites to dynamic, where your communication is happening all the time. It's not just click on a link and wait for a response. You're constantly interacting with these web applications. CDNs made all of that work. And a similar approach, really the same approach, is in many ways what enabled powerful cybersecurity defenses. Because cybersecurity also went through a pretty strong transformation about 10 years ago, maybe a bit less, where you moved from, our biggest concern being things like anonymous to sophisticated ransomware. And in the world of sophisticated attackers with ransomware and powerful DDoS extortion attacks, the centralized approach just wouldn't work. And again, you have to borrow from this playbook of math, distributed systems, algorithms, and that worked. AI today, I think, is in a very similar regime where as you move from training to inference, as you move from fairly low bandwidth and high latency types of interactions like the chatbot, where you're simply typing some text, waiting for a response, typing some text, waiting for a response. You move from that into an AI-powered application or an AI agent. The nature of the demand just changes dramatically. It becomes ubiquitous. It's constant. It's high bandwidth. It requires low latency. And the brute force approach just isn't going to work. You can't do this with purely centralized infrastructure. The demand has moved to the edge, so the infrastructure and capabilities of AI have to also move to the edge.